All right, so today we're going to be continuing to talk about methods. Last time I showed you a first basic example of a method and how it can be used to clean up a piece of code and make it a little bit more elegant. Uh, the next example we're going to be looking at today is along the same lines. This is based on an earlier example that I showed back on the loop lectures. I showed an example where I wrote a program that basically computes and prints all of the prime numbers from 1 to 1,000. Now, that original program was mildly complicated because it involved a nested loop structure. There was an outer loop that would iterate through the numbers that we're checking, and then to check each number to determine whether or not it's prime, there was an inner loop to do that work. Right now, especially anytime you have one loop inside another, that is a potential for things to get a little bit hard and a little bit confusing. So this is a prime candidate for potentially using something like a method to clean up the code and make it much neater. So the version that we're looking at here does precisely that. What this version is going to do is it's going to break out part of the work and put it into a separate piece of code, namely a method. All right, so the method we're talking about is right here. It's a method called isPrime, and its purpose is to take a single parameter, which is the number that you'd like to check out, and it's going to return either true or false depending on whether or not that number is a prime. And then inside the method, we put all the usual logic for doing this. One way to check whether or not a number is prime is to try all the possible divisors. So you start with the biggest divisor, n minus 1, and you drop into a loop, checking each divisor that comes along. And whenever you come across a divisor that divides evenly into the number, you stop the loop and you fall out. Then at the end of the loop, the only remaining question is, did you leave the loop early because you found a divisor, or did you run all the way to the end? And the way that you can tell the difference is that if you ran all the way to the end of the loop without finding the divisor, D will be 1 at that point. Right? So if D is 1, we can tell that we ran all the way through without finding any divisors, and therefore this number is prime. All right, and again, the overall goal of this method is to answer a question: is this number prime? And when you're answering a question, you're going to return either a true or a false value in response. So if you learn that the number is prime, the appropriate thing to return is true. Otherwise, if you learn that the number is not prime, the appropriate thing to return is false. Right, now, anytime that we're returning a true-false value from a method, the so-called return type of the method has to be set to this. This is a data type that we haven't talked much about. You may have read about this in the chapter on if-else statements. This is what's called the Boolean data type, and it exists primarily to handle these true-false values. So anytime that you're writing a method whose job it is to answer a question, almost in every one of those cases, the result is going to be this Boolean data type. All right, and because we've written a method that is useful for answering a question, it can be used in the context of an if statement. And you'll see that down here in the main part of the program, because in the main part of the program, what we have again is we have the loop that's going through a series of numbers looking for prime numbers. And for each number that we come to, we simply hand the work off to the method. And we use that method in the context of an if statement. So literally we say, if this number n that we're currently working with is prime, then what I'd like to do with that is I'd like to go ahead and print it. In this case, we're using a print writer, and we're printing all of our primes out to a file so we can collect all of them in a file when we're done. All right, so especially if you compare the structure of this loop here to what you would have seen in the original example that was computing primes and saving them, this code certainly down here is much cleaner. And this is one of the great benefits of having access to methods. Very often what methods allow you to do is they allow you to take some complicated chunk of code out of one part of your program and put it in another place. And the net result of doing that is it greatly simplifies the place where that complicated chunk of code used to be. All right, so this is really, forgive the pun here, but this is really a prime way to simplify a complex piece of code and make it much easier to understand. And if it's much easier to understand, the chances that you'll get it right when you're running the program go up considerably, because all other things being equal, easy code is code that's easy to understand is also easier to get right when you're writing a program. Okay, so any questions about this example before we move on to the next example? Okay, so again, today we're going to be going through a whole series of examples, and in each one of these, the theme initially is using methods to simplify something that used to be fairly complex. All right, now
Actually,
yeah, question.
sorry, I did just have a question on that last one.
Yeah, let
I
me bring
didn't
it
realize it till just
over
before
here.
you clicked.
Okay, what is your question?
Down at line 33, can you just explain how the if statement knows whether or not it's a true false answer?
Okay, so first of all, always whenever you write an if statement, the stuff that goes in parentheses in an if statement is always some sort of a question. Right now, up until this point, the way that we've been framing questions is by using comparisons. We've been doing things like this. All right, this is an example of a question you can ask. It's asking, is n less than 1,000? All right, well, it turns out there are other ways to make questions. Another way to create a question is to call a method. All right, and as long as the method that you are calling is designed to return a true false answer, that also becomes a perfectly legitimate way to ask a question. So you basically hand the work of answering the question off to the method. The method chews on the question a little bit, and it ends up giving you back a true or false answer. And then in turn, that true or false answer gets used for the if statement.
Okay, so if I say if is prime, that's like assuming if it's true, and then else would be false.
Right, and another way you could do this, if you wanted to be even more explicit about what's going on here, you could actually do a comparison here. You could do this. This is basically saying, let's call the is prime method, and let's look to see what answer comes back from it. And if that answer equals true, then we've passed the test. Right, some people may prefer that because it's a little bit more explicit what's going on here. We're calling a method that's going to return an answer, and then whatever answer comes back, we're going to compare that to true, and if it is true, we'll say that we passed the test.
Okay, I get it now. Thank you.
All right. Okay, so let's go on to the next example. And again, the purpose of the next example is to demonstrate how methods can potentially take some rather ugly code and make it much nicer looking. The next example I'm going to trot out is the example of this rather long and extensive card game that I showed in the lecture on if-else statements. This thing is really a vast number of if-else statements. If you're looking for an opportunity to get lots and lots of practice writing if-else statements, this card game is a prime example of that. Because what we have to do here is we have to manage a lot of complicated logic involving the rules of the game. So at various points along the way, we have to ask questions about how many points each of the players have. And most of the complexity in this particular piece of code is in asking all the questions that are necessary to play the game successfully. All right, now, unfortunately, I'm not going to be able to simplify this part of the program for you because that's sort of inevitably complex because it's all due to the rules of the game, and it's much harder to sort of clean this up and condense this down. But there is a part of the program that is a prime candidate for simplification, and it's near the beginning. And what this part of the program has to deal with is that one of the things going on in the game is we need to deal a series of cards. Again, it's a card game played with two players, and potentially each of the two players would need to have 3 cards dealt to them. So that means it's a total of 6 cards we need to deal with. And for each of those 6 cards in the program, there is a chunk of code that deals with that card. All right, so here's the chunk for card 1, here's card 2, card 3, card 4, card 5, and card 6. All right, and by the time you get done working with 6 cards, you've got quite a bit of code. This is somewhere north of 100 lines of code just to deal with dealing out the 6 cards to the players. All right, and furthermore, if you take a closer look at the way this code is structured, it's highly repetitive because the logic that you need to process card number 1 looks exactly the same as the logic to process card number 2 and so on. So there's a lot of redundancy and a lot of repetition here. Right? And as I said on the lecture on on Monday, when we were introducing methods, one of the reasons for introducing methods is to help to reduce this type of redundancy when you're writing code. Okay, so if we're going to replace this code with some methods, the first thing we need to do is we need to take a closer look at what the code is actually doing, because this chunk of code is actually doing several tasks. And for each of the tasks it's performing, we may need to write a separate method. Okay, so here's the first thing going on. The first thing is that we represent the cards by generating random numbers. We generate random numbers by using a random number generator. This command basically asks it to generate a random number in the range from 0 to 12. And to adjust that range so it falls in the range from 1 to 13, I go ahead and add another 1 to that. Okay, so each card is first of all represented as a number which falls in the range from 1 to 13, which represents the 13 possible cards that you could get. Now, the next thing you have to do for each card is you have to assign points to that card. And the story here is that all of the number cards in the deck are worth whatever their point value is, and all of the face cards are worth 10. All right, so to compute points, we have an if statement here. And the first thing the if statement does is it takes a look at the code number for that particular card and checks to see if it's greater than or equal to 10. If that's the case, the card is worth 10 points, and we go ahead and add 10 points for that particular player. Otherwise, the card is worth whatever its numerical value is, and we add that to the points that the player has. Okay, so turning the card number into points is one task that needs to be done. And finally, another task that we need to perform is we need to take, because eventually we're going to have some print statements that tell the players what cards they got. And when we print the cards, we would like to convert these code numbers into more friendly, user-friendly names for the cards. Right, so to do that task, there's a bunch of if statements here that basically convert the card code number to a corresponding name. Right, so the code number 1 gets turned into the word ace, and then the code numbers for the face cards get turned into the names of the face cards, and the code numbers for all of the number cards, they get turned into a string, which is just that number, and there's code here to do that. Okay, so what we have here is, first of all, a chunk of code that's being repeated 6 times because we have to deal with 6 different cards. And furthermore, within this chunk of code, there are separate tasks going on. One task is computing a point value for the card, and another task is converting the code number into a name that we can show to the user. Okay, so given all of this is going to motivate writing some methods, and for this reason, I'm going to switch to the second version, and in the second version, I'm going to introduce some methods that take care of doing some of these jobs. All right, so here's the first change that I made in the second version. I introduced 2 new methods here. One of these is to handle the task of converting the card's code number into points, and the second method handles the task of converting the card's code number into a string, which gives the name of the card. All right, and once you isolate these as separate tasks, the methods to do these tasks are fairly straightforward. All right, so for example, in the case of getting the points for a card, we need to get the right name for the method. We need to figure out what inputs need to come into the method. In this case, the only thing the method needs to do its job is the code number for the card. That's going to come in through that parameter there. And then the rest of the story is writing the logic. So we take the card number that determines initially how many points the card is worth. There is, however, an exception, and that is if the code number is greater than 10, the actual points for the card will be 10. So we'll knock the points back down for the cards number 11, 12, and 13. All right, and then when we have computed the number of points that the card is worth, we'll just return that value. And because what we're returning here is an integer, in the return type part of the method, we have to say that this is a method that returns an integer to you when you use it. All right, then we have the second method. The purpose of the second method is to basically convert a number to a name. So this is an appropriate name for the method. Again, it takes only one input, which is the code number for the card, and it then has some logic to convert that code number into text. Basically a collection of if-else statements that try to determine what the card number is. And once you determine which card number you're dealing with, it goes ahead and assigns a string to the name variable. All right, and the name variable is where our result is going to go, and that's the thing that we're going to return as the result at the end. And since we're returning a string, we say that's the return type of this method. Okay, so let me pause here and ask if anybody has any questions about the two methods that I just showed you. Okay, if not, let's now take a look at what having these methods will do for us in the code. Again, we have to, in the main code itself, we have to deal with 6 separate cards. And now the code for dealing with the 6 separate cards is quite a bit simpler. All right, because now in each of the cases, we have methods to help us do some of the work. And because we have pushed the work off to the methods, the code for handling each individual card can be much simpler. Right, so for example, the code for dealing with card number 1, that basically involves generating a random number for the code number. We then pass that random number to each of these two methods, and they answer 2 key questions for us. First of all, how many points is it worth, and what's the name of the card? Okay, so Mark, you've got a question for me here?
Yeah, so I see like method integer returns an integer and method string returns a string. What does method void do? Both?
Okay, so now occasionally what you'll see is you'll see a method that has a return type of void. We haven't seen any examples of that, but you may see some examples in the future. When a method has a return type of void, that basically says that it's not going to return anything. Right, now you might ask, well, what's the use of a method that does a calculation and doesn't give me an answer? Well, to see an example of a void method, we're going to have to see some examples of methods that do something useful without actually returning an answer. An example of this would be a method that is designed to save some data to a file. So its useful work would consist of doing a calculation and then computing some data and then dumping that data into the file. In that case, the method doesn't return anything to us, it just does a job. And because it's not going to return a value to us, we give it a return type of void.
Thank you.
All right, so again, the main advantage we see here is that once we've introduced methods to do some of these jobs, especially if we have to do some of these jobs repeatedly, being able to simply hand the work off to the methods and have them do the work for us is a very useful device for saving us space in the code. Right, and if you compare these two solutions side by side, the original solution that didn't have methods, if you go down and see how many lines it takes total to do all of this, it takes about 180 lines of code to do the whole thing. Right, whereas if we go to the version with methods, even though the methods themselves take up a little space when you write them, the payoff is that when you use them, they save a lot of space, and at the end of the program, we end up using only 120 lines of code. So net here, we've saved about 60 lines of code, which is pretty substantial. And that's one of the more useful things that methods can do for you. They can help make your code more condensed and more efficient and simply take up less lines on the screen. Okay, any final questions about this example before we go on to the next thing? Okay, now in each of the examples that we've seen so far, what we've done is we've taken some code that we've already written and we simply have introduced some methods in an effort to simplify the code and clean it up and make it nicer. What we're going to be doing next is something much more typical of what you're going to be doing when you're working with methods. And that is what we're going to be doing next is we're going to be writing a program from the ground up, and built into the development process itself will be the use of methods. All right, so I'm going to introduce a completely new problem to you, and we're going to write a program from the ground up to solve this problem. And built into the process of building the program will be the use of methods along the way. All right, so let me explain what this problem is. For this, we have to pull up some notes. the problem that we're working with here is a problem that involves the complexity of text. Right now, there are scientists who study reading in particular, and one of the things they try to measure when they study reading is what is the complexity of a piece of text. Right? And one of the tools that's commonly used in reading research is this thing called the Flesch Readability Index. It's basically a score that you can assign to a piece of text that measures how complex the text is. Now, somewhat confusingly, the score works backwards. When you have a very high Flesch Readability Index, it actually means that the text is relatively easy to read. All right, so here in the table at the bottom, here's the standard mapping from the readability index to the difficulty, sort of the education level of the piece of text. Right, so something with a readability index of 91 or greater, that's considered to be at the 5th grade level, and so on and so forth. As the index falls lower and lower, it goes to the highest level. And by the time you drop below 0, it's text that only a lawyer could understand. All right, so that's a standard scale for assigning a level of difficulty to a piece of text. Okay, now to actually compute this index, there is a formula. Presumably Flesch, who was the scientist who came up with this scale, gave us a formula for computing this index for a piece of text. Okay, now the formula is based on 3 quantities, and these 3 quantities are basically a measure of how complex the text is. The first of these quantities is called n sub p. It's simply a count of the total number of sentences that are in the block of text. The idea being that is, if the text is very long, it's likely to be more difficult to read, whereas on the other hand, if the text has relatively few sentences, it's going to be easier to read. So that's one of the factors that factors into the scale. Another thing that factors into the scale is n sub w. It's the total number of words in the text. This is also a measure of how long and how complex the text is. Also, if you combine that with a number of sentences, another thing you get is the average number of words per sentence. That's another measure of how complex text is, because in easy to read text, you have very few words per sentence, but in very complex text, you have lots of words per sentence. All right, so one of the factors that appears in the scale here is this ratio. It's the total number of words divided by the total number of sentences. That's a measure of the average number of words per sentence, and that's clearly reflects how complex the text is. And then finally, another thing that comes into play here is the difficulty of the individual words. And the way that we're going to measure that is by the number of syllables in the text. Now, again, what we'll use this for is to compute an average. We'll take the total number of syllables in the text and we'll divide it by the total number of words. What that gives us is a measure of the average number of syllables per word. Right? So if you have lots of very long, complicated words in the text, you have a very high average number of syllables per word, and that in turn increases the complexity of the text. All right, so what we're going to need to do is we're going to need to write a program that will open a large chunk of text and determine how many sentences are in the text, how many words are in the text, and how many syllables are in the text. And then from those quantities, we're going to compute these averages, syllables per word and words per sentence, and that then will give us an index. And then finally, at the end of the program, we'll have an if statement that looks at that index and prints a message saying what the difficulty level, what the reading level of that piece of text is. Okay, so before I move beyond this slide, does anybody have any questions about what the purpose of the scale and what it's measuring and how it's going to do it? Okay, so again, the key thing is we need to be able to open up a chunk of text and answer three key questions. How many sentences are there? How many words are there? And how many syllables total are there? Okay, now, rather than try to dive into this problem and start writing a program that will solve this straight off the bat, the first thing I want to do is I want to solve a number of technical problems that we have to solve. And then once we have a good sense of that we know how to solve these technical problems, then we can dive into the program itself. Right. So the first thing I'm going to show you here is I'm going to show you a series of shorter programs that are individually designed to solve some of the problems that we'll have to deal with in this overall problem. Okay, and the first one of these is the simple, it's closely related to the idea of figuring out how many words are in a text. So I'm going to start with this very simple program, which is sort of meant to get a handle on this idea of how many words there are in a text. Okay, now what this first program is going to do is it's not going to be counting the words. We'll add that feature later. The only thing I want this first program to do is I wanted to open up a file that has text in it and then try to read the individual words. And then as it reads the individual words, it will simply print those words out to the output pane down here at the bottom. Right, so what this will basically do is it will test whether our mechanics of reading one word at a time are working correctly. Okay, and the code here is very simple. It basically involves some ideas that we saw earlier when we were talking about files. The first step is to open up a scanner that reads its input from a file. In this case, I've already prepared a text file that has a block of text in it, and we're going to be reading from that text file. The next, we have some code that we've seen before. There's a while loop here that basically works its way through the file. And the main thing that we're going to need here as we're reading the file is we're going to need to try to read words one at a time. Okay. Now, fortunately for us, the scanner class has a method in it already that is designed to do essentially that. It has a method called simply next. And when you call the next method, it goes into the text and it gives you the next available word. So if you're interested in reading words one at a time, the next method is your friend. Right? And then also to control the loop, we use a has method, which is closely related to that. We use the has next method, which basically keeps running as long as the file still has words left in it that need to be read. Right? And again, all we're going to do in this example is we're going to, as each word comes in, we're simply going to print it to the output pane. So that way we can get a sense for how the reading process is actually going to work. Okay, so let's go ahead and run the program and see what it does. Oh, okay, sorry. Give me just a minute. This is actually based on a much earlier version of Java because I used this example for many years. What I need to do is I actually need to change the setup for this. Let's build here, compiling. There's a setting somewhere deep in here. Sources. Okay, oh, here we go. We need to change this. Change the binary format to 14. Sorry about that. Okay, so let's try again. Let's run. Okay, so here came the words. They flew by pretty quickly. There's quite a lot of words in the text. And if we just simply scroll down here, we see that this is largely successful. The only thing that's a little bit annoying is that when you print the words, many of the words get printed along with punctuation. Now, the reason for this is that when you call the next method, what it will do is it will start reading stuff from the file until it sees something that looks like a separator that breaks one thing from another. And the primary separators that this code is using are things like spaces, tabs, and line breaks. Right? So literally what it will do when you call the next method is it will start reading characters from the text, and it will stop reading when it sees something that looks either like a space, a line break, or a tab. Now, because the process does not stop when it sees something like punctuation, one of the unfortunate side effects here is that we're getting punctuation along with the actual words. Right? In fact, here's a more extreme example. For whatever reason, there was a chunk of text here where there was the end of a sentence, and I guess accidentally the space between the period and the next word got left off. So because there's no space here to separate these things from each other, it actually treated this entire chunk of stuff as a single word. Okay, so even though this is pretty close to what we want, it gives us a lot of things that look like separate words. In a few cases, it messes up. And so we need to tinker with this a little bit so we get something that looks more purely like words. Okay, so to fix that, I brought along another version, a small variation on this first program. And this one introduces one very small change to the program that is designed to fix some of these problems. All right, now the change that we're going to make here is what we're actually going to do is we're going to tinker with the scanner itself, and we're going to be using an option that you can set in a scanner that changes the behavior of the scanner. All right, here's what I'm going to do. I'm going to use this method. It's called the use delimiter method. And the way it works is you pass it a chunk of text, and inside the text are all the things that you would like to treat as delimiters. Right, so what I'm saying here is that the scanner should use a number of things as delimiters. So one of these is a space, another is the tab character, another is the new line character, another is the carriage return, and there's a bunch of other things that I would like to treat as separators. These include things like punctuation, quote marks, dashes, periods, commas, and even things like numbers, because somewhere in the text there may be dates, there may be years and things, and because I don't want to treat those things as words, I'm basically going to treat any number as a separator as well. All right, so what this will tell the scanner to do is that when it sees anything that looks like any one of these characters, it should simply skip over that and then go on and look instead for actual characters when it's looking for words. Right, so with that modification to the way that the scanner works, we'll now be getting output that looks purely like a list of words. Right, and this works pretty well now. If you go down the list of the output that comes out, what we're getting now is a great big long list of simply words. Okay, so that means now that we're able to actually take the text and very cleanly subdivide it into things that truly are individual words, we've solved one of our big problems, which is to simply count how many words are in the text. Okay, now, once we've seen this solution, once we've figured out how to count individual words, turns out that there's a very small and simple variation on this trick that you can use to instead count sentences. And for that, I brought along another example that's going to be working with sentences. And the trick here is to simply tinker with what the scanner considers to be a delimiter. All right, so what I've done here is I've done the same trick as the last example. I'm telling the scanner what it should be using as a delimiter, but here I gave it a much shorter list of possible delimiters. The only things I'm telling it to use now as delimiters are things that you typically see at the end of a sentence. That includes a period, an exclamation point, a question mark. Those mark the ends of sentences. And most importantly, since I did not include spaces in this list, now the scanner will no longer skip over spaces. When you call the next method now, what it will do is it will keep reading until it sees something that looks like one of these delimiters, and then it will hand you the entire chunk of stuff that it's read. This basically will make it possible for us to read one whole sentence at a time. All right, so if I run this thing now, it's going to be reading only full sentences, and that's what it's going to be printing. This is a little bit hard to interpret because this text is a little bit complex, and a lot of the sentences in this text are fairly long. Some of these sentences are so long that they actually span multiple lines of the output here. Okay, and one of the other things that I do along the way, beyond simply catching the individual sentences, I actually make a count of them as they go by, and at the end, it prints a little message telling me how many sentences were there. So this process was able to count the text and say, this text had a total of 29 sentences in it. Okay, so by tinkering around with a little bit with the scanner now, we have now solved the problem of getting individual words, and by using a slight variant on that trick, we've also solved the problem of getting individual sentences. All right, so those are the two key things that we'll need to count in this text. Okay, now the only thing that's left to do is syllables, because again, the last thing we need to count to compute this index is we need to compute syllables in the text. And to do that, we're going to need to have some way of going into the individual words and simply counting how many syllables are in each individual word. Okay, now this is the most challenging thing that we're doing, because to do this, we have to be able to break up words into their individual characters. And by examining the characters, we need to somehow get a count of the syllables. Right. Well, the key to finding syllables is to look for vowels, because if you take a typical word like the word presidents here, one key to where the syllables are is where the vowels are. This word has 3 vowels in it. It also happens to have 3 syllables. Now, the other thing you have to watch out for is in some cases, you'll have vowels that appear in a sequence. So for example, in this word here, in revolution, the I and the O, they form a sequence of vowels, and that's counted as 1 syllable. Right? So here, since we have basically 4 sets of vowels, the E, the O, the U, and then the pair, I-O, that counts as 4 syllables. Right? Now, that's the basic rule for how you count syllables in a word. But unfortunately, as with anything to do with text, there are complications. There are exceptions. For example, one of these exceptions is that sometimes a vowel does not mark a syllable. Here's an example of this. In the word empire, there are actually 2 syllables in that word, despite the fact that there are 3 sets of vowels. What's messing up the syllables here is that there is a silent E at the end. Right? And because the E is silent at the end, this counts as only 2 syllables and not 3. Another example is the word became. Again, it's got a silent E at the end. All right, so that's one important exception you have to watch out for, and the exception is that if there is a lone E at the end of the word, that by default is going to be silent, and you won't count that. All right, another example here is the word peace. Because peace has a lone E at the end, which is silent. This again is counted as only 1 syllable. All right, and finally, yet another complication is that this exception rule has an exception. And that exception is that if you have the letter combination LE at the end of the word, for example, the word able, A-B-L-E, if you have an E at the end of the word which has an L before it, in that case, the E is not silent, because that letter combination LE is pronounced L. So that's why able with the E at the end actually counts as 2 syllables and not 1, because it has an exception to the exception rule. All right, so those are the basic rules for counting syllables in a word. You basically look for groups of vowels, and the exception is that if there's a lone E at the end of the word, it doesn't count. And if that E has an L before it, it does count, right? So those are the rules for counting syllables. Okay, so now that we have solved some of these technical problems, and we know how to count words, and we know how to count sentences, and we also have a little bit of a grip on how you actually count vowels, we're now ready to write the main program itself, right? So here now is the code for the main program. And the first thing that you're going to see here is that what I've done is I've taken some of the ideas that I worked out in the earlier programs, and I have packaged them up into some code. All right, first example of this is this one. The purpose of this method is what we're going to do. I'm going to hand you a string that has a sentence worth of text in it. And what I want you to do is to basically tell me how many words are in that text. Okay, now to count the words, we're going to use the same trick that we used a minute ago. We're going to use the delimiter trick to help us break the sentence up into individual words. And I'll be using code similar to what I used a minute ago. The only other small difference here is that in this example, the text that I'm working with comes to me in the form of a string. And the trick I'm going to use here is I'm actually going to create a scanner that reads from the string instead of reading from a file or from the console. This is another thing you can do with the scanner. You can set up a scanner and say, hey, here's a block of text I want you to read from that. And then I'm also going to tell you how to break things up into words. And then we're going to go into the usual loop where we say, as long as there are more words left in the sentence, give me a word. And for each word that comes along, I'm simply going to count that. All right. Then at the end of that, I'm going to return the count of how many words I came across in the sentence. Yeah, so question here.
Yeah, so is a scanner S because you had string specified in the method?
Okay, Well, first of all, the reason that I'm using a scanner is I'm about to do a bunch of scanner things. For example, in the code that I showed you earlier, we had a scanner and I was using the next method and I was using the has next method. For that code to actually work, we really need a scanner, which is why I had to create a scanner in the first place here.
Okay.
All right, what's special about this scanner is that it's going to be reading its input from a string. And this turns out to be yet another way you can set up a scanner. You can start with a string that has text in it, and you can tell the scanner, read your text from this string instead of reading it from a file or from some other place.
Okay, so you just inputted S there for your own sake then?
Uh-huh. Right, and again, when I create the scanner variable, I can call that variable anything I like. Here, for simplicity, I simply decided to call that S. But again, whenever you set up a variable, you can choose any name you like for it. Okay, and the scanner itself will be working with whatever text comes into the method here when we call the method.
All right, thank you.
Okay. Okay, now another small method that we're going to need is a method that can take a single character as its input and answer the question, is this character a vowel? All right, so the first thing we're going to need here is we're going to need some way to pass a single character to this method. And the way we'll do that is by using a special type of parameter called a char parameter. Java has a data type, it's called the char data type, that is used to store individual characters. So if you're going to be working with a single character, the correct type to use for the parameter is this char type. Right, and all we're simply going to do is we're going to set up an if statement here that checks to see what character is in that CH. And if that character is any one of these vowel characters, we'll return true. If it's anything else, we'll return false. All right, so that's a simple method for answering a question, is this character a vowel or is it not? Okay, now once we're able to look at a character and answer the question, is it a vowel or is it not, we're then ready to start thinking about counting syllables. All right, so here now is a fairly long and complex method. And the way this method is going to work is it's going to take a single word as its input and go through and scan the letters in the word and try to figure out how many syllables are there. Okay, now the first thing that we need, a little bit of a technical trick, is that if somebody gives you a string that has an entire word in it, and you need to get access to the individual characters in that word, there is a handy method in the string class that can do that for you. That method is called char at. And the way that works is that the individual characters in the word each have an index number. The index number of the very first letter in the word is index 0. So if you'd like to ask what is the first letter in the word, you use the chunk of code that I've highlighted here. You use the char at method with an index of 0, and that will give you the first character that shows up in the word. All right, and what I'm going to do is I'm going to immediately take that character that I've gotten and pass it along to the isVowel method. And that method can say, true or false, is this thing a vowel? And if it is a vowel, I'm going to go ahead and count this as my first syllable that I've come across. Okay, now, next what we need to do is we're going to set up a loop, which is going to do this same trick many times. Next, what we'll do is we'll work our way through the rest of the letters in the word. And to do that, we'll be setting up a loop that works with an index. The next letter in the word is at index 1. And this loop is going to keep going through the different index values until it comes to the last one. And you can tell that you're at the last letter in the word by checking the length of the word. All right? And as soon as the index equals the length of the word, we've reached the end and it's time to stop. All right, so this is a loop that will go systematically through the letters in the word. And for each index we come to, we'll get that letter by using this code, and then we'll pass that letter off to the isVowel method, and the isVowel method will be looking for vowels for us. Okay, now again, the general rule here is that each time you come across a vowel, it marks the presence of a syllable. But the thing you have to watch out for is you have to make sure that you don't overcount things, because again, when you have a pair of vowels in sequence, like the A and the I in this word, that pair of vowels does not count. Right? So the way we're going to work this is that whenever we come across a vowel, we will count that as a vowel if the thing before it is not a vowel. Right? So for example, when I get to the A, that will count because it's a vowel and the thing before it is not a vowel, so the A counts. But when I get to the I is a vowel, but because the thing before it is also a vowel, that won't count. Right, so that's a trick that we're going to use to make sure that we don't overcount our vowels, especially when they form groups, because in a group, we're only going to count the first vowel in the group, and we're not going to count any vowels that come after that. Okay, so to implement that rule, we need a little bit of a slightly complicated if statement. And again, what the if statement is doing is it's checking to see that the thing at the current position is a vowel, and the thing at the position before it is not a vowel. All right, that's the only instance in which we want these things to count, and those are the only vowels that will count. Okay, and then finally at the end, when we get to the end, the last thing we need to check for is exceptions. And to handle exceptions, we've got another chunk of logic here. And what the exceptions will do, the first thing it will do is it will go and get the index of the last letter in the word, and it will check to see if that last letter is actually an E. Because if the last letter in the word is an E, that means that we're in danger of having a silent E. And if we're in danger of having a silent E, what we need to do is check for the exception to that exception, right? And in that case, we would check the letter before the last letter and see if it's an L. And if we have an LE combination, that does count. But if we see anything but an LE combination, we're going to say, that last E is silent. What I need to do is I need to uncount that final E. So to do that, I'll reduce the count by 1. Okay, so the logic's a little bit tricky, but if you get the logic right, you'll be able to handle the silent E at the end special case correctly. And once that special case is handled, you'll now have a reliable count of how many syllables are in the word. Okay, so again, let me pause and ask if anybody has any questions. Yeah, so any questions you'd like to ask here?
I have a question.
Mm-hmm.
So for the rule that you're doing the 2 syllables in a row and we're not counting the second one,
Uh-huh.
in the word later on in the sentence colonial, doesn't that have 4 syllables?
Okay, so let me find
For
the
the
word.
I,
So roughly, where is the colonial?
2 rows down from the highlighted word.
Okay, yeah,
And
colonial.
a little bit to the right.
Oh yeah, okay, you've got me there, because it turns out that there's yet another exception. You're right, there are some instances where things will actually be pronounced. You're exactly right. In that example, the word colonial, that would count as 4 syllables, yet my rule would count that as only 3. All right, so it looks like I need to go back to the drawing board, and it looks like there are yet more exceptions that we haven't handled correctly. So tell you what, since we're just about out of time here, I can basically, we'll run out the clock on this example. What I will do is I will go back and code in the logic to catch that counter example. And then when we come back next time, we'll finish up this example. This gives me a good excuse to sort of go off and fix this and come back and show you the fixed version later.
Another similar one, like the word ranked, that would be ranked if it were counted like this. But that one, how is it possible to have an exception?
That's a very obscure exception, because actually in that one, the word ranked, I think that does technically count as 2 syllables, even though there isn't an actual vowel sound in the second syllable. I think most people would count that as 2 syllables, ranked, because I think the rank part is separate from the d part at the end. So I think that technically counts as 2 syllables. I think we can let that one slide.
Mm-hmm.
Okay. Okay, at any rate, we're out of time today. I ran over a little bit. So when we come back on Friday, the first thing I'll do is I'll wrap up this example after putting the colonial fix in, and then we'll finish this example and go on and say some more stuff about methods. All right, so until then, The other thing that I'm going to do is in a few minutes, I'll be posting the recording of today's lecture. And when I do, I'm also going to be posting some suggested reading on the website. The material that we're looking at comes from chapter 6. So I'm going to be posting some suggested reading in chapter 6. So you'll want to open that chapter and start reading that. Stay tuned for that. That'll be posted in just a few minutes. Okay, so again, I'll see some of you in lab tomorrow, and the rest of you, I'll see you back